Welcome to the 29th video in the series of research methodology titled Research Design. I am absolutely thrilled to guide you through today's explainer because honestly, this is arguably the single most critical phase of any study you will ever conduct. I want you to think about it this way. Building a research study without a solid plan is literally exactly like constructing a house without a blueprint. You might have the absolute best materials, the finest construction team in the world, and the greatest intentions, but without a clear structural plan, that house is eventually going to collapse. And it's the exact same thing in research. Your core idea might be absolutely fascinating, a real game changer even, but without a suitable design holding the whole shebang together, you are simply going to fail to produce valid, reliable, and meaningful findings. Okay, let's dive right into this with a truly fantastic definition from C.R. Cathari, who is a major leading voice in research methodology. He defines research design as the arrangement of conditions for the collection and analysis of data in a manner that combines relevance to the research purpose with economy and procedure. Now, what Cathari brilliantly highlights here is the dual need in our research architecture. First off, you need relevance, meaning your design actually has to help answer your specific, real-world research problem. If it doesn't do that, what are we even doing, right? Second, you need economy. Listen, research is incredibly expensive and it takes a ton of time, so your design must ensure you are using your time, your budget, and your personal energy as efficiently as possible without wasting resources chasing down dead ends. So, to construct a study that truly stands the test of time, we are going to follow a 5-step architectural arc today. We'll start with drafting the ultimate blueprint, then gather our essential building blocks, choose your design type, bring in the inspector for validity, reliability, and ethics, and we will finish up with some common mistakes to avoid. Section 1. The ultimate blueprint. Imagine yourself as the lead architect right now. You've been tasked with planning a highly complex investigation, and the academic community demands that your work is systematic, it's logical, and it is totally scientifically sound. At its core, a research design is the organized plan and logical framework that guides the collection, measurement, and analysis of data to answer your research questions efficiently. It's so much bigger than just picking a single method, like waking up and deciding to use a survey or an interview. A strong blueprint keeps your entire study tightly focused and completely manageable. It connects your deep, underlying philosophical assumptions all the way down to your specific, granular methods of data collection. By laying this entire framework out way in advance, you save vital time and money because you know exactly what you were doing on day 1, day 50, and day 100 of your project. And most importantly, it helps you maintain strict control over unwanted, extraneous variables that could just completely throw off your entire investigation. Moving on to Section 2, Essential Building Blocks. These are the raw materials we absolutely must define before we even think about pouring the concrete for our study. Everything starts with a very natural chronological progression. Step 1 is the research problem. This is your foundation gap, the specific issue or situation in the real world you actually want to investigate. For instance, maybe you're looking at something like low achievement in mathematics among secondary school students. Now, if this initial problem is vague, your whole study is going to be incredibly messy. That clearly defined problem naturally dictates step 2, which is your objectives and questions. These translate that broad problem into specific, measurable aims, something like comparing traditional lecture methods to interactive activity-based methods. And finally, this leads seamlessly into step 3, your hypotheses. These are the testable predictions you make. You take your question and you form a very precise expectation about how one factor is going to affect another. Speaking of factors, there are 2 primary types of variables you absolutely have to understand here. So the crucial point is clearly distinguishing between them because they act as the main load-bearing pillars of your entire study. First is the independent variable. This is your presumed cause. It's the factor the researcher actively manipulates. Going back to our math class example, the independent variable would be the specific new teaching method you introduce to the classroom. This variable directly influences the dependent variable, which is the outcome or the effect that you measure at the end of the day. In our scenario, the dependent variable would be the student's final academic achievement scores on their math test. Measuring these 2 variables accurately and controlling for any outside nonsense is literally the key to maintaining strict control in our research structure. Once your variables are locked in, you need to quickly define the rest of your materials. You have to clearly identify your population, which is the entire target group you want to draw conclusions about, but obviously you can't test everyone, so you need your sample, which is the realistic, representative subset of that group you'll actually study. Then you select your tools and instruments, things like validated questionnaires, standardized tests, or maybe observation checklists. But listen, remember this. Even the absolute best measurement instruments in the world will produce terrible, useless data if your data collection procedures and your data analysis plan aren't meticulously detailed out in advance. You have to know exactly how, when, where, and by whom the data will be collected, and exactly what techniques you'll use to make sense of it all later on. Whether that means running complex statistical regressions or coding hundreds of pages of interview transcripts, you need a plan. Okay, Section 3, choosing your design type. Just as architects design completely different styles of houses for different environments and client needs, researchers must choose a specific design type based on the unique problem they are trying to solve. Before picking a specific layout, you have to decide on your overarching approach, quantitative or qualitative. Quantitative research focuses heavily on numerical data, strictly measurable variables, and rigorous statistical analysis. It is highly objective and very structured. You can think of it kind of like building a highly controlled, tightly engineered smart home, where every single dimension is measured to the exact millimeter. Qualitative research, on the other hand, explores deeper meanings, lived human experiences, perceptions, and organic social processes. It involves things like open-ended interviews, focus groups, and rich field notes. This approach is much more like building a deeply complex, flexible narrative structure that adapts to its environment and the people living inside it. Both are incredibly valid, they just serve different purposes. Let's look at how this builds out into specific models. Descriptive research simply describes what currently exists. Think of something like broadly surveying student reading habits across an entire school district. Experimental designs, well, those are the gold standard for establishing strict control. Here, you actively manipulate a variable, like rolling out a brand new teaching method, to definitively prove cause and effect. Quasi-experimental is very similar, but it's used in messy real-world scenarios when you can't randomly assign subjects, like if you're comparing two existing pre-formed classrooms. And correlational designs allow us to simply observe relationships between variables as they naturally occur in the wild, such as linking study habits to grades, without actively trying to prove direct causation. Continuing our tour of design types, causal comparative research looks at existing group differences where you can't ethically or physically manipulate the cause, like comparing grades between urban and rural students. Case studies provide an incredibly deep dive into one specific instance, like spending an entire year analyzing a single, highly successful inclusive school. Historical research looks at past documents and archives to understand exactly how present conditions developed over time. And this all brilliantly illustrates the ultimate combination, mixed methods. This is where researchers combine quantitative and qualitative data. Think about executing a massive, broad, 1,000-person survey to get the hard data, and then conducting 20 in-depth follow-up interviews. You get both the structural numbers, like a 75% approval rating, and the rich qualitative paint, the personal stories behind those numbers, to really finish the house beautifully. Section 4. Validity, Reliability, and Ethics. It is officially time for the building inspector phase of our explainer. This is where we ensure our house is safe, structurally sound, and ready to withstand some serious academic weather. First up is validity, which is the ultimate test of our structural integrity. Validity proves that our findings are actually accurate, meaningful, and not just the result of a flawed blueprint. Validity is supported by 4 distinct pillars. Internal validity means your study accurately shows a true causal relationship without any outside interference messing it up. External validity means your findings can actually be generalized beyond your specific study setting to the wider world. Construct validity ensures you are truly and accurately measuring the specific theoretical variables you claim to be measuring, and statistical conclusion validity means your math, your sample sizes, and your analytical results are fundamentally sound. You need all 4 holding the roof up. Now, if validity is our structural integrity, reliability is the consistency of our building materials. Reliability is the consistency and dependability of measurement. What this means in actual practice is that if another researcher takes your exact blueprint and builds this exact same house again, meaning they repeat the study using your methods under similar conditions, the house should hold up exactly the same way. The results should be virtually identical. If your data collection procedures are completely random or inconsistent, your findings simply cannot be trusted, no matter how beautiful the research design looks on paper. It's like building a house with bricks made of sand. Next, we absolutely have to talk about ethics. These are simply the foundational building codes for how we treat people during our research. A design that ignores participant safety, privacy, or dignity is completely unacceptable in the scientific community, regardless of how methodologically brilliant it might seem. We always look to the Belmont Report for our 3 core operating principles. Respect for persons requires absolute, voluntary, informed consent. People need to know exactly what they are signing up for. No tricks. Beneficence is the strict commitment to minimize any potential harm to participants while maximizing the benefits of the research. And justice requires the fair, equitable selection and treatment of all participants, ensuring no specific group carries the burden of research alone while another group gets all the benefits.
And finally, Section 5, Common Mistakes to Avoid.
I really want to share the structural failures that researchers often make during the design phase, so you can avoid these incredibly costly disasters. Pay close attention to these common pitfalls because missing even one of these elements can cause your entire research project to collapse into bias and completely invalid conclusions. The first major failure is choosing a design that simply doesn't match the problem, like trying to use a simple one-off descriptive survey to make massive cause and effect claims. You just can't do that. The next is using vague or poorly defined variables, which makes accurate measurement virtually impossible. Then you have weak, unrepresentative sampling, meaning your findings can't be generalized to anyone outside your tiny, specific group. Using unreliable tools will absolutely guarantee you collect bad data. Ignoring extraneous variables means you let hidden, outside factors skew your results entirely. And finally, failing to plan your data analysis before you actually collect the data means you might just end up with a massive mountain of numbers or interviews that don't actually answer your core research question.
So, as we wrap things up today, I leave you with this final, truly critical question. Is your research built to last? By meticulously planning your research design, selecting the absolute right variables, maintaining strict validity and reliability, and always prioritizing ethics, you ensure your scientific contributions will stand strong for years to come. I truly hope this blueprint helps you construct some incredible, highly impactful studies of your own. Thank you so much for joining me today. If you found this explainer helpful, please take a moment to like, comment, share, and subscribe to this channel for more methodological blueprints. See you in the next one.